got our week 2, which is Algebra Part 1. Now, the reason it's Part 1 is Algebra is a huge part of this course. So what we're going to do is split Algebra into a few weeks, so they're not lots of information. So let's just get going. Our first topic, we're looking at expanding triple brackets. The easiest way to show you this is actually to just take an example. So here's an exam question. You've got to show that we've got a triple bracket minus another x multiplied by a quadratic, and we're looking, and then we're going to have to factorize it afterwards. So let's take the first two terms. And I'd always suggest you make your working super clear. In case you make a mistake, you're getting marks each time you're multiplying out. So if I take these, I've got x times x. So I've got x squared plus x plus 3x plus 3. So altogether, I've got x squared plus 4x plus 3. And out of the 5 marks, that's essentially 1 mark. I'm now going to take my quadratic, which I've multiplied out, and I'm going to multiply it by x plus 4. And when I do that, I multiply everything by x first. So x cubed plus 4x squared plus 3x plus 4x squared plus 16x plus 12. Right, and then you're going to simplify that. So altogether you end up with x cubed plus 8x squared plus 19x plus 12. Right, so that's opening out that first batch. Now altogether you've now got 3 marks. So we've got the other 2 marks to get, and we take what we've done, 19x plus 12 minus, and remember it's the whole thing minused. So what I would do is actually take every number and every value, or not number, they're not numbers or values, every letter or expression within that bracket and multiply it by minus x. So you're not doing too many lines and you're not confusing yourself. Because if you're going to go wrong on this, the likelihood would be that you would go wrong when you're opening out that expression. So we've got x cubed minus x cubed, so that disappears. 8x squared minus 7x squared, leaving us with x squared. 19x minus 11x, leaving us with plus 8x. And then we've got 12. And we want to be able to factorize that. So I'm looking for factors of 12, which add up to 8, which is 6 and 2. So there's our first expanding triple brackets. Right, next we're going to be looking at a question where they don't give you something and they talk about coefficients. So remember, a coefficient is effectively the bit in front of. So the coefficient of x squared is the bit that's going to be in front of your x squared. Right, so let's open this out first. So we're taking the whole of this bracket and multiplying it by x. So we get x cubed plus 5x squared plus kx. We're now going to take the whole of the bracket again, and this time we're going to be multiplying it by minus 3. Minus 3x squared minus 15x minus 3k. And we want to know our coefficient of x squared. So I'm looking for everything that is in front of an x squared. So that's in front of an x squared, and that's in front of an x squared. And we know that's equal to everything that's in front of the x. So in front of an x, we've got plus k and minus 15. So now we've got 5 minus 3 equals k minus 15. So we'll have 2 equals k minus 15. Therefore, k equals 17. So k equals 17. Right, next questions. Now we've got changing the subject of the formula. Now I know you guys have been doing this, particularly if you're doing further maths, since probably year 9. But let's see, and let's look for the most efficient method. So this would also be exactly the same type of question you would get in a level 9 question in your maths paper. Okay, so let's have a look. We want to rearrange, we want to make P the subject. Now we don't like things on denominators to start with. They just make life a little bit difficult. So let's get rid of anything on the denominator. So if I have a look, I've got p and I've got 3p. I'm going to take the largest value, because it's a multiple of the other one, and multiply everything by it. So if I multiply everything by 3p, I get 3pm. If I take this and multiply it by 3p, the p's going to cancel, and I'm going to left with the top of it multiplied by 3. And if I multiply the last one, I'm going to end up with that. Now what I want to do is open everything out and put all my p's onto the left-hand side. So I've got 3pm equals 6p plus 3 plus p plus 5. So now I'm putting all my p's onto one side, 3pm, and I've got 6p plus p, so I can move those, so minus 7p, equals 3 plus 5, which is 8. And the next step is you want to take the p outside the bracket. So 3m minus 7 equals 8, and you should then be able to see p equals 8 divided by everything in that bracket. Now you may have moved it the other side. You may have minus 8 equals 7 minus 3m, which is essentially this expression times by minus 1. And that's totally fine as well. So whichever answer you got, it's the correct answer. So you may have it written in a slightly different form. It would still be the right answer. Okay, we're going to use that same strategy for the next bit. So we look at the denominator. Anything on the denominator, we've got x, y, and y. So okay, we take the one with the most things, which is x, y, and I'm going to multiply everything by x, y. If I take the first term and multiply it by x, y, I'm left with 1. Take 4 and multiply it by x, y, I'm going to get 4xy. If I take 3 over y and multiply it by xy, I'm left with the y's cancel, and I'm just left with 3x. Right, now I've got all my x's already on the same side of the equation. So I can rewrite this just because we're used to it. I think it looks a bit prettier having the on the left-hand side. Remember, all this means is like, I don't know, 2 plus 3 equals 5. You could write it as 5 equals 2 plus 3. It doesn't matter as long as you swap it all. I'm going to take x outside the subject, outside the bracket even. So we get 4y minus 3 equals 1. So now we're going to divide by 4y minus 3, leaving us with x equals 1 over 4y minus 3. Again, you might have done it a slightly different way. It looks slightly different. As long as the expression is the same, you're okay. You've got it correct. Okay. Next one. Simplify. Right, whenever you see simplification, you're going to think factorize, factorize, factorize. Take out common denominators. So even if you can see everything, in this case, there isn't anything too obvious, but say you could see everything could be divided by 2. Doesn't matter, factorize first. So at the top, I'm going to take out of the bracket, if I have a look with the numbers, 15 and 5, I can take 5 outside. X squared and x, I can take x outside. And y squared, I can take y outside. So this is going to be multiplied by 3x, and this one is going to be multiplied by y. On the denominator, so the bit on the bottom, I'm going to say, well, from 12 and 4, well, both numbers go into 4, and that's about it. So I'm going to get 3x minus y. And what you notice is these two cancel out beautifully, and we get 5xy over 4. Okay, let's try this one. All right, so we look at the numbers again, and on the top we're going to go 8 and 50. So we can take out 2. They're both even numbers. And it's x cubed and x. So I can take x outside the bracket. So if that's not clear, that should be 8x cubed minus 50x on the top. And then I'm going to have 4x squared inside, and I'm going to have minus 25. Right. And then we'll have 2x on the bottom, and this hopefully is a double bracket. So I'm going to say, however you do your, however you factorize, that's totally up to you. You could do 6 times 35. You could look at it and go, well, I know I've got 2 numbers that multiply to 6, and I've got 2 numbers that multiply to minus 35. There's various methods to do the factorization. We'll make sure there's a separate video because that obviously applies to GCSE as well. But I'd like to think you can do that if you are at this point in your, if you're doing your further maths. If you can't, not a problem at all. My hint would be, if we have a look at the top, hopefully you recognize it's a squared minus b squared. So we know that's a difference of 2 squares. So we're going to take the top and we can write it as 2x plus 5, 2x minus 5. And because they're asking you to simplify, you would recognize that one of your brackets has to be 2x and 5, at which point you can then figure out the other bracket. Right, so let's cross everything out. Now it's all multiplied that we can by each other, leaving us with 2x plus 5 over 3x plus 7. Remember, everything needs to be multiplied by something in order to cancel it out. Otherwise, you can't cancel it out. So be really, really careful with that. No crossing random x's out. If in doubt, think about what you would do with numbers. Okay? So something that sometimes when we're doing the algebra, we get a little bit confused, but think, what if they were numbers? So if I had 5 plus 2 over 5 plus 1, I can't just take out the 5s. It makes no sense. So it's 7 over 6 is definitely not the same as 2 over 1. Right, some more factorization. And here is where the difference comes between your GCSE and your further maths. Right, we've got something like this and you're like, what do I do? I know we've got squareds. So you see squareds and you think, okay, 2 brackets. Okay. I know that the first value times the last value has to give me 6x squared. And I know the last one times this one gives me minus 20y squared. So we're going to go about and think about how we do that. But hopefully you realize before you even start that everything goes into 2. So I'm actually going to take 2 outside the entire thing first. So I get 3x squared plus 13xy minus 10y squared. Right, so I got to this point and it makes it easier now because there's only one way to get 3x squared. I've got to have 3x and x, right? Which makes it a little bit easier because now I'm thinking of 10y squared minus 10y. Now I know if I use 10 and 1, 10 times 3 is 30, not going to give me 13. And then 10, if I had a 10 here, if I had a 10 over here and a 1 here, I've got 10 and 3, but there's no way for that to become minus 10. Because even if I had minus 10x, and then this would have to be plus, and then we're not going to get 13. So we know we're not using 10 and 1. Other factors of 10, 2 and 5. If I had a 2 here, I'm going 3 times 2 would be 6. And then I've got 6 and 5 together, they're not going to give me 13. Let me try the other way round. 3 times 5, 15. And multiply these 2 together. If this was a 2, we're like, okay, great. 15 minus 2 gives me 13. So the way that you think about it is, if this is a negative here, you know that you want, so if this is a minus, you know that you're taking away these two multiplied by each other to give you this. So we end up with 3x minus 2y and x plus 5y. Another way that you can do this is you can remove sort of the x or the y, and then as long as you put it back again. So for example, if it's easier for you, say I had 3x squared plus 13x minus 10. Okay? And I know that you might use the method where you do 3 times minus 10 and you get minus 30. And then you're looking at factors. So you go, how can I get 13 from that? So I've got 30 and 1, that doesn't work. 2 and 15, that works. So I can do 3x squared plus 15x minus 2x. So I replace. So this is made up of these two, minus 10. Then I take my first two terms and take a common factor. In this case, it's 3x. And I get x plus 5. And I can take x plus 5. I want x plus 5 here. So I get minus 2. So factorize, this gives me 3x minus 2, x plus 5. And then what you can do is the numbers on their own, put the y back in. That's also a perfectly valid method. So my final answer, don't forget the 2 there, is 3x minus 2y, x plus 5y. I hope that makes sense and I haven't overcomplicated it. But if you find that difficult, get rid of one of the letters. So the one that's at the end, factorize and stick it back in again. Okay, index rules. Right, so we know from GCSE, we know if we've got x to the power of something, the x has to be the same, so that base number has to be the same. We're going to get a plus b. We know when we divide, we can take away the powers. We know when we do everything to the power, we're actually multiplying. And then we come to things that are a bit more complex, where we know that x to the 1 over n will be the nth root of x. And x to the minus n is 1 over x to the n. So we've got our rules. And also always, 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 x to the power of 0 is always 1. Now, obviously, when we move things to the other side, we're going to do the opposite. So in this question here, you've got 3 minus root x to the third equals minus 2. Now, to the power of a third means the cube root. So what's the opposite of cube rooting? So that's going to be cubing. So for both sides, I'm going to cube, which means it gets rid of the third on one side, and I've got minus 2 cubed. So we've got minus 2 times minus 2 to give us plus 4, times minus 2 to give us minus 8. So we get 3 minus root x equals minus 8. I can take away 3 from both sides. So I'll get minus root x equals minus 11. They're both negative, so I can just make them positive. Root x is the square root of x. The opposite of square rooting is to square it. So 11 squared gives us 121. Here they're telling you what to do. But if they hadn't told you to multiply both sides by x to the half, how would you have known that was what you needed to do? So the way that you could have looked at this is to say 2x to the power of 3 over 2 minus 3x to the half equals 7. And because x is to the power of minus a half, we know that it's on the bottom. Because remember, x to the minus n is 1 over x to the n. The 7 is not to the power of anything. The 7 doesn't also go on the denominator. Be very careful about that. Okay, so I'm looking at that. I don't like things on the denominator. So I'm multiplying everything by x to the half. So I get 2x to the 3 over 2 times by x to the half minus 3 x to the half times x to the half equals 7. When we times indices, it's the same as adding them. So 1.5 plus a half is going to give us 2. A half plus a half just gives us 1. So we get 3x. And we can bring the 7 over. And there we go. We've got a quadratic again. And because it says 3 significant figures, we know that we're going to be using the formula. If it's a calculator paper, you can just stick it into your calculator. And it will be a calculator paper actually, because you won't be able to do the square root without it. So you can put it into your calculator and sort of work backwards. The other alternative is to use completing the square. So in your calculator, if you've got the ClassWiz calculator, you can tell menu, equation function, polynomial, degree 2, and we're going to do 2 minus 3 minus 7. And it gives us our roots, and it will give us our answers. But because we're asked to show our working, you could either write out the formula. So there's 2 methods to do this. So if I say method 1, you're going to say a equals 2, b equals minus 3, c equals minus 7. And you know that x equals minus b, x equals minus b plus and minus the square root b squared minus 4 times 2 times minus 7 over 2 times 2, and then just read off your answer. So we're going to read off our answer. So x equals 2.77 or minus 1.27. Now, which one isn't valid? Remember, we can't take the square root of a negative number. It's illegal. Dividing by 0 and square root of a negative number. If x was minus 1.27, over here, where you've got x to the half, you would be taking the square root of a negative. So, to cross through that, that's not valid. So this is our answer. That's the first way to do it. And you're just sort of writing out your entire formula and then using your calculator. The other method, so say method 1, method 2, would be using completing the square. So step 1, I would take that equation, and because it's got an equal sign, I can divide it by 2. So x squared minus 3 over 2x minus 7 over 2. I can now complete the square. So I can do x, half what's in front of the x, 3 over 4, squared, minus 9 over 16, minus 7 over 2, equals 0. And you could double check that was correct, because your calculator also gives you the minimum, which we can see is 3/4, and the y, which is minus 65 over 8. And then we can rearrange that. So we get x minus 3/4 squared equals 65 over 8. Take the square roots, so you get plus and minus, and you end up with exactly that. So it doesn't matter which way you do it, you're going to show your working, even if you've just plugged it into your calculator, and your answer is 2.77. Right, binomial expansion. Okay, so you've learnt this using Pascal's triangle, I assume, because that's how normally we learn it there. So let's draw up Pascal's triangle. We're going to the 6th term, to the power of 6 rather. So remember, Pascal's triangle is because if you have a plus b, you've got 1a to the power of 1. You've effectively got 1a plus 1b. So 1 and 1. If you've got a plus b squared, you're going to have a squared plus 2ab plus b squared. So the coefficient of the first one is 1. In the middle it's 2, and then it's 1. And what we start to notice is when we add these two, we get that, and there's always 1s on the outside. So if I had a plus b cubed I get a cubed plus 3a squared b plus 3ab squared plus b cubed. So every single time, the first term is going down in power, and the second term is going up in power. Okay? So if we think about this, we've got 2x plus a to the 6, and we're looking for the x to the 4 term. So in the first one, so if we go all the way, so 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. Right. In the very first term, this one here will be just 2x to the power of 6. Then it's going to be 2x to the power of 5, 2x to the power of 4. And we realize that happens at this point here, when this is our coefficient. So what we know is if we had a plus b to the 6, I would have, like I said, a to the 6 plus this coefficient here, 6a to the 5b plus 15a to the 4b squared. So when we get there, we stop because we've got our to the power of 4. And we're going to say, well, let's substitute things in. So here, if you like, if I match things up, our a is the same as, and I know they've used the same letter, it's very annoying because it's not a in this case. A is 2x and b is what they've called a here. So let's stick that into our formula. So 15, 2x to the power of 4, and then you've got a squared. Right, so let's open that out. 15 times 2 to the 4 times x to the 4 times a squared. Okay, so we know if it was actually in a calculator paper, but let's say it was in a non-calculator paper. 2 to the power of 4 is 16. 16 times 15 is going to give you 240. So we've got 240. We're not worrying about the x to the 4 goes at the end. A squared x to the 4. So now what we're looking at is we're looking for the coefficient. Remember, the coefficient is the bit in front of. So the bit in front of x to the 4 is 240 a squared. So 240 a squared we know is the same as 60. Right, rid of our zeros. A squared is going to be 6 over 24, which is a quarter. If I take the square root, remember we get plus or minus. So the square root of 1 is just 1. The square root of 4 can be plus or minus 2. So I get a half, or I get minus a half. So a half or minus a half. Okay, now we're going to go to linear and quadratic inequalities. Linear inequalities, a lot more straightforward. You treat it like an equal sign. If you've got a double one, whatever you do to one side, you have to do to the other. With a quadratic inequality, I'll show you how to do it if you don't have your calculator with you and it's a non-calculator paper. However, if you have your calculator, you can always check things because you've got an inequality button on the class whiz. If you haven't got the class whiz, that's fair enough. If you're going on to do A-level, you will need it for A-level, so you might as well get it now if that is a possibility. Okay, so let's take the first question. It tells us to work out, and they bold things for a reason, that's there to help you, the integer values. So these are the whole numbers. But first, we want to get x on its own. So if we have a look, we've got 4x plus 3. So we're going to minus 3, and because there's two sides to this, we're going to minus 3 on both sides. So if I do minus 5 minus 3, I'm going to get minus 8. 13 minus 3 is going to give me 10. Now I'm going to want x on its own, so I'm going to divide by 4. So when I do that, I have to divide both sides by 4, which leaves me with x minus 8 minus divided by 4 is minus 2. And then we've got 10 divided by 4, which is the same as 2.5, 5 over 2. So let's write it because we're trying to 2.5. And now we want to list all our integer values. So we know x is greater than minus 2, but not equal to, because it doesn't have the equal sign. So it's not going to be minus 2, it's going to be minus 1. Next one up, 0 is an integer. 1, 2, and I can't go any further. So those are all my integer values. Right, work out the range of values for which x squared minus 11x plus 28. Step 1, factorize. So I'm going to do that. X and x. 20 factors of 28. There's a plus here. So factors of 28 that add together to give me minus 11. So we're going to say, well, 7 and 4, and it's going to be minus and minus. And so I've got what we call our critical values. So my critical values are 7 and 4, because if I was to solve this equal to 0, I'd get 7 and 4. There are a few ways to do this. First way is, which you may have learned, is to think about, it's a positive quadratic, so it's a smiley face, it goes through 4 in my very dodgy graph there, and we're looking for wherever this graph is above the axes, meaning if I take any value of x and I read off the y, it's always going to be positive. Now it's only ever going to be either between the two numbers or outside of the two numbers. It's never going to be anything else. You're never going to get a random mix. So either your values are going to be between 4 and 7, or they're going to be less than 4 and greater than 7. So if I'm here and I go, that's positive. Whereas if I go in between and I read off a value, it's negative. So I want where it's positive, which in this case is when x is less than 4 and x is greater than 7. Okay, right. The other way to do this, or it shouldn't really be and, but we don't even need that actually. Let's take that and out and not confuse you. So, because you wouldn't have two answers at the same time. So technically, me sticking an and there wouldn't be correct, although you would get all the marks. So you'd have, let's have a look, and you'd make sure you put them both in your answer. Right, like that. The other way is we've got this 4 and 7. We know it's got to be between them or it's going to be outside. So I pick a number. 0 is usually the best number if 0 is not one of your answers. So I could have 0 minus 0 would just leave me with plus 28. And you'd say, is 28 bigger than 0? Yes, it is. Which means 0 has to be part of my solution. 0 is less than 4. So it's the outside bit, so x is less than 4 and x is bigger than 7. So I think a graph sometimes is easiest to see. It's that region there, but you can do it any way that makes sense for you. Okay, let's have a look at the next question. Identities. Because this is a new idea, I think a lot of students find this difficult. But actually, it's one of the easiest topics. So your general method's going to be, you're going to open up all the brackets on your left-hand side and your right-hand side, and then you're going to match coefficients. Okay, so underline, highlight. I use a highlighter when I do this. In the exam, it doesn't matter as long as you're working. It's all done in your correct colour pen and, you put it at the bottom and your final answer is really clear. So we're going to take our left-hand side and open out the brackets. So when we do that, we get 3a times 2x, so 6ax minus 3a plus 4ax plus 20. So I've done 3a times 2x, 3a times minus 1, plus 4 times ax, plus 4 times 5. And that's equivalent to 60x plus b. So now I'm going to say to myself, on the left-hand side, what is in front of the x's? So on the left-hand side, I've got, let's redo that. On the left-hand side, I've got 6a, that's in front of an x. Take the sign with it, and plus 4a. Okay, and on the right-hand side, I've got 60. Then I'm going to take everything that doesn't have an x. Remember, a is just like a value. That's not an x or an x squared or anything we need to worry about. So we take minus 3a, we're adding 20, and we've got b. Right, so now let's write all the bits that we had in yellow together. So we've got 6a plus 4a must equal 60, because that's the coefficients of the x. So we end up with 10a equals 60, so therefore a equals 6. Right, next one, we now got minus 3a plus 20 equals b, but we already found out a, so we can substitute it in. So we're going to do minus 3 times by 6, right? So minus 18 plus 20 equals b, so b must be 2. And don't forget to write your answers into the answer box, especially if you're somebody who's working, can sometimes get a little bit messy, so it makes it super clear. Right, so let's take one that's a little bit trickier, or, you know, has more than one letter where you have to think about it a little bit more, but not really. Hopefully this is okay. Do exactly the same. We're going to take the left-hand side. We've already got mx, so that's easy. Plus 4. And now we've got minus 2 multiplied by x. So we've got minus 2x. And then always take the sign in front of the number of your bracket. That way you're never going to get yourself in a muddle. Minus 2 times p, so minus 2p. Okay? And that's equivalent to 6x plus 6. Right, we're going to take everything in front of our x's. So I've got an m in front of an x and minus 2 in front of an x. And here we've got 6 in front of an x. Then everything else that's not in front of the x. So plus 4, minus 2p, and plus 6. So now what I've ended up with is my yellow bits, if you like, the bits in front of the x, m minus 2 equals 6, and 4 minus 2p equals 6. So the first one's going to give us m equals 8 by adding 2 on both sides. Here we've got to do minus 4 first from both sides, so we get minus 2p equals 2, so p equals minus 1 when I divide by minus 2. Go back and fill out, so 8 and minus 1. Okay, so I hope that's been useful. Tune back next week, we've got more algebra. If you've got any questions, stick them in the comments. Let me know. The idea is we're going to keep working through this. We'll go through the specimen. I think they've given you 2 specimen papers which are on the website. We'll go through those, and then we're going to try write you a predicted, well, not really predicted, it's more like practice paper for further maths, which I will upload into the classroom. And we'll be going through that in a course in May half term, so just before your exam, which you are welcome to sign up and join. Obviously, all of these are free on YouTube. That will be a paid course for a few hours, but you should have all the information by going through these. So that's just if you want that extra boost just before the exam. But we've got Algebra Part 2 next week, and you're going to have 1 a week for the next 5 weeks. If anybody, you won't be able to access the videos till those weeks, but if you would like to access the questions in advance, we'll try have the questions up for you in advance on Zahra Classroom, so you can try them all, and then as you go through the video, you can work through it and double check your answers. Hope this has been useful. Leave any comments, questions, and yeah.